Yes, in the last 2 weeks, we have primarily dealt with data metrics, both for individual data and also regarding the relationship between two different data samples. And in the third week, we specifically want to concentrate on the concept of probability. And for that, I have brought a motivating or perhaps not so motivating example that you have probably all encountered in your daily lives over the past few years, namely corona tests, and of course the question of what happens if you have a positive test. How certain can they really truly be that they are indeed actually infected or not? And this is related to how high the actual viral load is in the environment. And as motivation, I would like to introduce you to a type of task, a very practical type of task that we can look at after the videos from this week, and we will be able to calculate it with all the topics we have discussed. And this is the following. So imagine you are in a city. We have about 1 million inhabitants, and we know how many confirmed cases of COVID-19 there are. So we know the incidence, as we have always called it, and we have a test, and we know the test well. And you know this when you open such a test in 2001. On the package insert, you will see two values that describe the test. This is the sensitivity, which describes the probability that the test will be positive in an infected person. So if I am infected, how likely is it that the test will indicate that that is 95%? And then there is the specificity 2001, which is the other case. Namely, that the probability is negative for a non-infected person. And of course, if the test is good, both values should be relatively high. And now comes the part where we have a resident, and she actually has, that's basically what interests one in the end. She has a positive test result from 2001, and she is now wondering, what is the probability that I actually have corona? So, should I maybe take another test or not? That would be one question. And the other question that we want to answer is, how does this probability change when the incidence changes? Namely, the interesting thing is that how meaningful such a test is actually depends on the incidence. When the incidence is low, the probability that I do not have corona when the test is positive is greater than when the incidence is high, because the overall population is then smaller or larger, and we want to deal with such types of tasks. For this, we need conditional probability, concepts of probability, and in the end, the formula that we will calculate or look at once at the very end, which will then enable us to solve such a task. But in the next video, we will first start with the basics, with the fundamentals that we need in elementary probability theory. Until then,